TypeScript generics provide a way to create reusable components like functions, classes, interfaces, etc. that can work with a variety of data types while maintaining type safety. Generics allow you to define placeholders for types that are determined by the caller of the generic component. Let's dive into the code. Generics are denoted by angle brackets and type parameters within those brackets. Here we have a new method named generic identity that has a couple of interesting pieces. First, we have this t in angle brackets. This acts as a placeholder for a specific type. Next, we have this parameter argt followed by :t, which tells us that this function takes a type t and returns the same type of argument. So, for example, if t was the type number, this would mean that the argument being passed in must be a number, and the value being returned from this function must also be a number. Now let's see this in action. Let's create some variables. First, we'll create a variable here. Let's call it result. For the result variable, we'll set its generic to a number and pass in the number 10. Next, we'll create a variable called message, and for this variable, we'll set its generic to a string. Here we'll pass the word hello. Now, if we log these, we can see they both work as expected. Get 10 and hello. However, if we were to change the generic of our result variable from a number to a string, we can see we get an error. Argument of type number is not assignable to parameter of type string. That's because our argument doesn't comply with the generic type we're enforcing. This number is 10 and it's not a string. TypeScript also offers type inference with generics. Take a look at these same two variables. You might notice a subtle difference. This time, instead of explicitly declaring the generic, we're allowing TypeScript to infer those for us. Since 10 is a number, it infers a type of number. Since hello is a string, it infers a type of string. Generics can also be used in classes. Really quick, guys, if you'd like to learn more about ES6 classes in JavaScript, be sure to check out our Mastering ES6 course free on our YouTube channel. Okay, let's get back to generics. Let's go ahead and define a new class. We'll call that class box. As part of that class signature, we set a generic here. Within the class, we create a new private variable and set its type to our generic. Next, we'll add a constructor using the generic in our argument and assign this.item to item. Pretty standard class structure. Finally, we set up a method that returns the item and, of course, supply the return value of that method with our own generic. Now we're able to instantiate new objects using our class and defining a custom type for each. First, let's create a box of numbers where the generic type is number. Next, we'll set up a box of strings where the generic type is string. If we log those out, we'll see we get exactly what we expect. Get 10 and we get hello. Last but not least, generics offer something known as constraints. Generic constraints in TypeScript allow you to specify constraints on the types that can be used as type arguments for generics. This means that you can restrict the types that can be passed to a generic type parameter based on certain criteria. Let's look at some examples. We'll start with an interface constraint. In this example, lengthwise is an interface with a length property. The log_length function uses a generic type parameter t constrained to the types that extend lengthwise. As a result, the function can only be called with arguments that have a length property. Let's use the log_length function in a few different ways and see what we get. So in this first one, when we're passing the word hello to log_length, we're basically asking how big is the word hello lengthwise? Or for this array that consists of 3 numbers, we're asking how long is that array lengthwise? Get it? Okay, good. You'll notice we get an error on the final function, but not the first 3. This is because the first function's argument is a string, and strings have a length property. The second function's argument is an array, which has a length property. The third function is an object that explicitly provides a length property, whereas the fourth function's argument is just a simple number, and the number type does not have a length property. So let's log this out and see what we get. We get 5 because the word hello has 5 characters. We get 3 for the second log because the array consists of 3 items. And then for this final log, we get 5 because that was explicitly what we set our length value to. Next, we have something called the key of constraint. In this example, the getProperty function takes an object obj and a key, both with generic types T and K. The type parameter K is constrained to be one of the keys of type T using key of T. This ensures that only valid keys of the object obj can be used to access its properties. Constraints can be a little complicated, but I promise it'll all make sense in a second. Let's drive this home with some sample variables. Let's say we have a person object with the following properties: name, age, and city. Now let's say we set up some variables here that call our getProperty method to return some data from the object. You'll notice everything is error-free except for that final salary variable. This is because the person object doesn't have a key of salary. In the past, these types of mishaps would cause all sorts of issues in large-scale applications. But now with TypeScript, the problem is flagged before it even passes the linter. Let's comment this offending code out and run our code. And that works as we would expect, right? Our person.name property, or our person's name property, is John. Our person's age property is 30, and our person's city property is New York. Let's recap the key benefits of generics in TypeScript. Generics allow you to write reusable code while maintaining type safety. TypeScript enforces type constraints on generic types, helping catch type-related errors during development instead of after. Generics promote code reuse by enabling you to write functions, classes, and interfaces that can work with a variety of data types. And lastly, generics provide flexibility by allowing functions and classes to work with different data types without sacrificing type safety.